And let's get one more thing going. What happens when I know a factor? Example. I know 3 divides 111. How do I know that? Because if you add those, 1 plus 1 plus 1, that's 3. So I know I could take 111 and write that as 3 times what? Well, if I know 3 is a factor, then I could go on the side and divide to figure out what this number is, which is this number. A factor means the remainder is going to be 0. Let's see. 3 divides 11 3 times. 3 times 3 is 9. Subtract. That would be a 2. Bring the 1. 7. 3 times 7 is 21. So now I know, if you give me one of the factors, I know 3 times 37 will give me 111. Right? Also, I could say 2 and 5 are factors of 210. What does that mean? That means I could take 210 and say that is 2 times 5 times, and let's go about this the long way. Let's start with either. If I write the 5 there, 5 divides 21 4 times, that's 20. Subtract. 5 divides 5 divides 10 2 times, that's a 10. What does that mean? That means, so far this is what I got. $210 equals 5 times. Now, this is what I do. I'll take the 42, I'll take what's left, and I divide that by, they told me a 2 as well. I'll divide it by 2. 2 divides 4 2 times, subtract, and 2 divides 2 1 time. So I'll write the 2, and then I'll take the 21 and say, okay, you know what? I know 21 is 3 times 7. So actually, 210 is 2 times 3 times 5 times 7. I just factored that. Given me 2 factors of a value, I could take whatever of course, there's another way of doing this. You could also say, look, 210, 2 divides 2 1 time, right? A 0 and a 5. 5 divides 10 2 times, and 5 divides 1 time. 3 divides a 7, and you could, we're not after that, we're after the actual process of division. The goal is really to get this answer, to factor so you could graph. I want to graph this. That's the goal. How do you graph it? Well, you need to factor it. And once I factor it, I know all about the graphing because we did all of these awesome examples. So, if I look at this problem, they're telling me 4 and -3 are zeros. What are they saying? They're saying f of 4 equals 0 and f of -3 equals 0. Isn't this remainder? That's like somebody saying, hey, if you add 1 plus 1 plus 1, you get a 3. Guess what? 3 divides 1, 11. You don't know that it's 3 times 37, but you know it works. Somebody's telling you that f of 4 and f of -3 give a remainder of 0. That's what that means. And if that's the case, that means x minus 4 and x plus 3 is a factor of this polynomial. So, if I start with, let's say, the x plus 4, well, I'd rather syntactic division over long division. So I am certain of one thing. I'm going to end with a 0 when I do this, because they just told me that. Well, drop the first number, that's a 4, add those, -5, -20, -8, -4, that's -32, isn't it? Yeah, that's a positive 48. And what's 4 times 48. That is 32. That is 16, 17, 18, 19. What do you know? I knew that already. The important part is that when I get to the next factor, I'll use it on what's left. I'll use it right there. The goal is to factor this so I can graph it. Drop the first number. Again, I know the remainder is going to be 0. How do I know that? They told me that already. Drop the first number. 3, negative 2, negative 6. That's negative 14. What's 3 times 14? 12. Something's not right. What's not right? What did I miss? Okay, 1, 3, negative 2, negative 6, negative 14. That's not gonna give her. Oh, negative 3. My mistake. I'm glad these mistakes are coming up so you don't make them. Negative 3, negative 8. That is 24. That is negative 16. And what is 16 times 3? That is 48. Negative. No. That's a positive. So that's negative 48. That's a 0. So far so good. What does it say? Factor each polynomial with the given zeros. Okay, well, let's see how this works. Do you know what that means? I have left. I start with x to the 4th. This is x cubed, and this is x squared minus 8x plus 16. Hey, I know to factor that. Times x, the opposite of that, times x, the opposite of that. So this means, this is saying f of x equal x to the 4th minus 9x cubed plus 12x squared plus 80x minus 192 is actually x plus 3 times x minus 4 to the 3rd. And we know how to sketch the graph of any of those, right? Negative 1, negative 2, negative 3. See how that gives you a negative 3? It's right there. And do you remember we did the zeros 1, 2, 3, 4 right there? Remember how these were opposites? This is x to the 4th. If you put x equals 0, you get negative 192. Let's say that's negative 192. And left to right, multiplicity on this is a 1. So this runs straight across. And the multiplicity on this 0 is a cubic. How do you make that look like a cubic? You erase that. There you go. And connect that with the other piece. Again, if it was really negative 192, you would have plenty of space to really make that connection. And that's what we're going for. So we're going to do this again. And they're telling us 6 and negative 2 are zeros, which tells you on the graph, this graph crosses at negative 1, negative 2, and 6. That's what that means. That's what the zeros mean. This is x to the 4th. I already know the endpoints. Negative 196 is the y-intercept. So now what? Now I need the rest. Well, how does that work? Let's take the 6. 1, negative 10, a 20, a 40, and a negative 96. Drop the first number. That's a 6, negative 4, negative 24. Add those, negative 4, negative 24. What would that be? Negative 6. No, 16, isn't it? Yeah. And what's 6 times 96? Can you guess? What's 6 times 16? 36. 6, 7, 8, 9. A remainder of 0. They already told us that. We already know that. 6 is going to give us 0. And guess what? negative 2 is going to give. And what are we going to get? How are we going to benefit out of this? We're going to continue where we left off. Drop the first number. That's a negative 2. That's a negative 6. Multiply those. That's a 12. 12 minus 4 is an 8. And oh man, I keep on doing that. That's a positive. Yeah, okay, there you go. Otherwise it doesn't match. And that will be a 16 negative, and that will be a 0. And hey, we're back to stage again, the same deal. Isn't this x squared minus 6x plus 8? Wouldn't you say that's x minus 4 into x minus 2? And if you tag this on, if negative 2 is a 0, then x plus 2 is a factor. And tag this on, x minus 6. So wouldn't you say that this polynomial f of x is actually x minus 6, x plus 2, x minus 4, and x minus 2? Look at that, it has everything. So the zeros are already there. The two zeros that I just found are negative 4 and negative 2. Well, if you set them equal to 0, that's right there and right there, right? X minus 4 will be 0 at 4 and at 2. And do you see the multiplicity on all of this is a 1? So left to right, this is really opening up, and here it's going to come down, and it's going to look like a straight line around each of these zeros. And look at that, there it is. They're not asking for the graph, but I'm going to ask you for the graph. I'd like to look at the next problem. They tell me 3 and negative 2 are zeros. Okay, well, the goal is to graph this again. If they tell me that this graph crosses at 1, 2, 3, and you know what? 2 more. Let me spread those out. At 3 and negative 2, and I already know the y-intercept is negative 54, but I know there are 2 more zeros to go, unless there's multiplicity. Well, let's start with the 3. I'll take the 3. 1, negative 7, 9, 27, and negative 54. Make sure if one of those is missing to put a 0 for. 1, 3, add those, negative 4, negative 12, add those, negative 9, 18, 54, a 0. Very good. Got it. The first 0 worked out. The second 0, I'll continue on where the first one leaves, and it doesn't matter which one you do first. Throw up the first number, negative 2 and negative 6, multiply those, that's a 12, that's a 9, negative 18, and a 0. And this is x squared minus 6x plus 9. Well, I know what that is. That is x minus 3 squared times the yellow factor times the blue factor. The yellow factor is x minus 3, and the blue factor is x plus 2. So this is actually, this f of x, if you factor this, that is actually x minus 3 cubed x plus 2. So this is a 4th degree polynomial. It looks something like this. Left to right, the negative 2 is multiplicity 1, it crosses down, and we know what a cubic look like. So I need to really erase this and make it look like a cubic. There we go. And then I continue on. This is going to go up and connect those any way you like. And there it is. And what if they went backwards? What if they told me, write an equation of polynomials expanded form? If these are the only zeros, that means f of x is, if this is a 0 on the graph, that means x, the opposite of that is a factor, the opposite of that, and the opposite of that. Now for a test, this is more than enough. They do multiply this out, not a big deal. I could multiply those. That is x squared minus 13x plus 40. And here I'm going to distribute the x times all of those, that will be x cubed minus 13x squared plus 40x, and the 1 times all of those will be plus x squared minus 13x plus 40. If I combine like terms, what is that? 27x plus 40. And of course, the hard part is going backwards. The easy part is the multiplying, even though it's kind of tedious, but it's easier. Here, f of x is x, the opposite of that, the opposite of that, and the opposite of that. And this is fine answer on the exam, but if you multiply those out, those are conjugates. That's x squared minus 4 x cubed minus 4x squared minus 4x plus 16, and this function is actually x cubed minus 4x squared minus, oh, it's right there. I shouldn't have wrote it again. It worked out perfectly.